Welcome back, Wolfpack. Today's lesson is 6.8, Density and Modeling Geometry. Our essential question is, how is density related to area and volume? Density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. And I heard a teacher say one time that D equals M over V. So like the DMV, the Department of Motor Vehicles, where you go to get your license, if you can remember DMV, density equals mass over volume. You also can define density in other situations that involve area or volume besides mass per unit volume. For example, the population density of a region or the population per unit area can also be found by using the density formula. So the population density is equal to the population divided by the area. So how crowded an area is would be its population density. If you think about the amount of people that live in the Everglades versus the amount of people that live in Cape Coral. Cape Coral is denser than the Everglades. There are more people that live in the same size area in Cape Coral than do the Everglades. So population density in real life is how crowded is a place. And we would use population density to help us determine when to build schools, or when to build restaurants, or when to expand roads. So that's the real life application of population density. So we're going to do example number 1 together in class because it has multiple parts. But let's do example number 2. Burlington, Vermont has an area of about 160 square kilometers and a population of 109,000 people. What is the approximate population density of Burlington? So population density, PD for short, is population over area. So that's going to translate into 109,000 people divided by 160 squared kilometers or kilometers, however you would prefer to say that. And then if you divide 109,000 by 160, I believe you get a decimal, but you cannot have a partial person. So we're going to round up to the nearest person. And so that would be 681 people. I should have written people right here. I apologize. People per square kilometer. So that means in every square kilometer in Burlington, 681 people live there. Okay, so you just divide the population, the number of people, by the size of the space. Let's do another one. This one also has to do with Vermont. The state of Vermont has a population of 626,000, so we're going to need to know that. Vermont's territory can be modeled as a trapezoid as shown in the figure. So here is our trapezoid. Okay. Each unit on the coordinate grid represents 1 mile, so technically these are miles. It says 1 mile, but technically we just do it in miles. And they want to find the approximate population density of Vermont. So population density, again, is the population divided by the area. Well, I do not know the area of Vermont, but I can find it using the area of a trapezoid formula. The formula for area of a trapezoid is base 1 plus base 2 divided by 2 times the height. Okay? So the upper base of the trapezoid is 20, 40, 60, 80 miles. And the lower base is 40 miles divided by 2. And Vermont is 20, 40, 60, 80, 100, 20, 40, 60, 160 miles tall. So 80 plus 40 is 120, divided by 2 is 60. So 60 times 160. And we have 9,600 square miles. So that's the area of Vermont. So before we could find population density, we had to find the area of Vermont, which means we found the area of a trapezoid. So now we're going to come back over to our problem. Our population is 626,000 people. make sure you're writing your units, divided by 9,600 square miles. So when you divide 626,000 by 9,600, our population density is approximately 65 people per square mile. 65 people per square mile. And if you worked it out, you saw that it was a decimal, but again, rounded to the nearest person. So that's why I said approximately 65 people per square mile. So that's how we find population density, and we do regular density the same way, mass divided by volume. But again, I want to do example number 1 with you in class because it's a little bit more in-depth. It just has more parts to it. A British thermal unit, also called a BTU, is a unit of energy. You might have heard about it in your science classes. It's approximately the amount of energy that's needed to increase the temperature of 1 pound of water by 1 degree Fahrenheit. So if I wanted to get my water from 98.6 degrees to 212 degrees, I would need however many BTUs to get it to move up from 98.6 to 212. The energy content of a fuel may be measured in BTUs per units of volume. So, example number 4, it says a spherical tank is filled with a gas and it has the dimensions shown. When the tank is filled with natural gas, it provides 116,151 BTUs. Find the number of BTUs produced by 1 cubic foot of the gas and round to the nearest BTU. So we would need BTUs divided by the volume. So we know that our density is equal to our BTUs, which is 116,151, divided by our volume. Now, they did not give us the volume. Excuse me, I'm going to sneeze. Sorry about that. I couldn't pause it fast enough. So, I'm sorry, 116,151 BTUs. And we're going to need to divide it by our volume, which we don't know our volume yet. So we're going to have to come over here and solve for volume. The volume formula for a sphere is 4/3 pi r cubed. So 4 over 3 times pi. Our radius is 3, half of 6, cubed. Okay? So 4 over 3 pi times 27. And then 4 times 27 divided by 3 gives us 36. So our volume is 36 pi feet cubed. And I can come over back to my equation and type in 36 pi feet cubed. So now I can find my density because I have 2 numbers, and I'm simply going to divide 116,151 by 36, and then divide it by pi again. Or if you want to find out what is 36 times pi, the 36 times pi is 113.0973. And so then you would divide 116,151 by 113.0973. And you have your density. So 116,151 divided by 36 pi, density is equal to, it says round to the nearest BTU, that means the nearest whole number, 1,027 BTUs per cubic foot. Notice I have this unit per this unit. That dividing line right here means per. So 1,027 BTUs per 1 cubic foot. So population density and BTUs and regular density, they're simply dividing a number by another number. Mass divided by volume, population divided by area, or BTUs divided by volume as well. Okay? We will do examples 5 and 6 in class together. But hopefully this gets you prepared for class. Thank you for doing your homework with fidelity, and I will see you next class.